Okay, this is lecture 2 of this series, What is Mass? Now, if you recall, just to reiterate, Bohr's model talks about atoms being constituting of a nucleus which has protons which are positive charged, neutrons which are neutral, and electrons which occupy space around that nucleus. So it's a central nucleus. Space is occupied by electrons, and the high probability of an electron being, say, for instance, in a particular radius around a nucleus is pretty much it's pretty much the highest probability is that it will be in a given radius around a nucleus. And the more protons and neutrons that it has, then obviously the bigger the radius, so really the bigger the atom is. So not only is it bigger because it has more stuff in the middle, but it's bigger because it needs more space in which these electrons will be flying around it, okay? All right. And this, we can talk about temperature later on, and for instance, why it is that things cannot get to absolute zero. And that pretty much has got to do with the energy that's required for getting these electrons to go around this nucleus. In other words, as long as they're moving, there's energy, and as long as there's energy, there's temperature, and therefore it would be impossible to get to, if there's any matter there, it would be impossible to get to absolute zero. And then there's this philosophical questions about what if there's no matter, what is it? And these are some of the questions that you can ask, and I'll be happy to go through them. All right, now let's have a look at this. So number one, we asked the question, what is mass? And the definition, the very definition of this mass is right there. So the mass is defined by the number of protons and neutrons in a particular atom. Okay? The electrons, the mass of the electrons is so negligible that we pretty much discount it. If we were using this model to work out mass of a given amount of stuff, we would not consider the electrons. Okay, so here's an example. Oxygen has 8 protons. So eight of those red things in the middle of the, if you like, in the nucleus of oxygen, 8 of them, and it will also have 8 neutrons, so 8 of these green ones as well, okay? And so that constitutes really the bulk of the nucleus of oxygen. Like I said, the electrons, the 8 electrons around it, which it will also have, are negligible in terms of how much there is. Okay, so we have atomic mass is 8 plus 8, so we have 16 grams for every mole. Now that begs the question, what is a mole? And basically it's defined like this. So we've got 6.02 by 10 to the 23 atoms. If we put this many atoms together, we would call that a mole. Put this many cars together, we have a mole of cars. Put this many houses together, we have a mole of houses. This many pens, we have a mole of pens. Whatever it is, if it's got this many in it, 6.02 by 10 to the 23, we have a mole of it. Okay? And a mole of it is 16 grams. That's the mass. So mass, if you want to think about what mass is, it's this many things, this many atoms together constitutes the mass of a particular thing. So if you divided that, you would be able to work out, for instance, what is the definition of mass for one of those things. All right, well that's just simple maths. I'll leave that up to you. Okay, so what is this 6.02 by 10 to the 23? If you aren't already maths inclined, if you are already maths inclined, then that you pretty much understand what that is. If you are not, then in simple terms, I'll just stand on this side so you can see the whole lot, and you can see down there, look at all of those. those. So you've got 6 and 23 other figures, okay? 21 of them will be, is it 21? Yeah, 22, yeah, 21 of them will be, 22 of them will be zeros, but it'll be 602 and then followed by 21 zeros. So, do you want to try and say this to yourself? 602 hundred trillion, billion, million, thousand trillion, billion, million atoms. That's what is going to make up 12 grams of carbon. So carbon 12 is going to be 12 grams of it, will be this many atoms of carbon. So if we try to picture that in terms of say real life, you can imagine what your average pencil looks like. I can't see one straight away. All right, so everyone knows what a nice fresh new pencil looks like. Well, imagine that pencil was weighed 12 grams. So if you put it on a scale, it would read 12, and it was made out of carbon 12. Okay, so in other words, carbon 12 being 6 protons and 6 neutrons. Okay, so carbon 12, 6 protons and 6 neutrons. If it was made out of that, just carbon 12, then it would weigh 12 grams for this many of those atoms. And there you have mass. Answers that question up there. Okay, now, some of you will be asking, well, if I look at a periodic table, why does it say 12.01? And that would be a very good question, because if all of them have an integer as the mass, for instance, if I said oxygen had 8 protons and 8 neutrons, and it came to 16 grams per mole, how come I could get something like 15.9999, which is what the actual atomic mass of oxygen is? Or how come I could get 12.01? Well, this is because of what I explained in the earlier lecture, and that was the isotopes. Because carbon has different isotopes. For instance, carbon 12. Okay, so carbon's got 6, so we've got 6, carbon 6 has 6 protons and electrons. Protons and electrons. And 6 neutrons makes it 12 altogether. So this is carbon 12. Okay, so carbon 14, for example, which is used for which has radioactive decay, and that's why it's used to measure, to date things with. So, and we know how quickly it decays. The decay is called the half-life. Okay, so that's how much it decays by, and we know how long that takes, so we can practically use it like a clock. So carbon 14, for instance, we'll have carbon. It'll have 6 protons. Remember, if it didn't have 6 protons, it wouldn't be carbon, would it? Okay, if it had 7 protons, it would be nitrogen. If it had 8 protons, it would be oxygen. Okay, as it turns out, it still has 6 protons, but it's got 8 neutrons. That's what makes it different. So it slightly has more mass, because if we had this many of them together, remember, if it was carbon 12 and we had this many of them all together, it would be 12 grams. Well, if we've got carbon 14 and we've got this many of them together, we're going to end up with 14 grams for every mole. Okay, so this is a mole, 6.02 by 10 to the 23, and we'll have 14 grams for each mole. For all of these will add up to 14 grams. Grams is what we, you and I, talk about as being mass. So that defines mass. So now think about mass like that, and then later on when we discuss things like gravity, which includes mass, then you can refer back to this understanding of what mass means, okay? And then we can tie those things together. I've got quite a very nice little explanation for how Einstein gravity works in not a very technical way, so I think you'll enjoy it. I've run it a few times now, and it gets better and better each time I do it. I think you'll enjoy it. Anyway, okay, so just in a nutshell, it explains all of this. So here is the model of here is the model. I'll stand on this side. Here is the model of the atom. The bulk of the atom resides in the nucleus. We know that mass is defined by the number of protons and neutrons in the nucleus. Because the electrons are so small, they're negligible in terms of its mass. We actually don't take that into account at all. So certainly not from that aspect. We might take it into account in terms of energy. For instance, E equals mc squared. We would take pseudo mass into account. For instance, when we're talking about photons. Okay, so but we'll discuss that. There's some lectures to come that will go into relativity, and I'll explain some of that to you. Okay, so in a nutshell, mass defined by the number of protons and neutrons in the atom. Okay, and then we've said here that oxygen has 8 protons and 8 neutrons, so that gives it an atomic mass of 16 grams. 16 grams per mole. Now, as I said to you before, a mole, 6.02 by 10 to the 23 atoms makes 1 mole. You can say this, that's it right over there. If you want something realistic, look, this would be my guess about how big this number would be if you wanted to think about that. If you went to your average beach and picked up 1 grain of sand and had a look at it, and then thought to yourself, I wonder how many grains of sand there are on this beach. Well, in all likelihood, there would not be this many grains of sand. Okay, so that gives you an idea about how big that, how small an atom is, and also how many of them would be taken up to make just 12 grams of carbon. Okay, so I hope that sort of gives you an idea about what mass is. If you have any questions, please feel free to ask any questions in the comments, and if you want to see more of these, then obviously click the subscribe and then that little bell there, and every time I put one of these up, you'll be able to know that it's here. Okay, all right, so thank you, see you next time.